Hello and welcome back to my workshop. My name is Robert. Been quite a while again. Mainly I've been busy doing nothing, especially over Christmas. But late last year I did do a couple of machining projects and video them. This video will be the one that survived. Most times people show their mistakes on camera and I don't object to doing that. But in this case I can't. Allow me to elaborate. So in the middle of last year I decided that I'd like a rear mounted tool post for my lathe. The main driver behind this was to do some left hand threading using the Ainjest. Now I know you can turn over the tool and use it on the front of the lathe and run the lathe in reverse, but I just fancied making a rear mounted tool post, so I made this out of a piece of steel that I'd obtained. This is rather tough stuff, as it turns out. I made this as far as I could entirely on the shaper. Obviously you can't drill the holes. I even made plans to how to cut the T-slots on the shaper. However, this is just too tough for my little machine and there was too much chatter to cut the T-slots. But everything else was done on the shaper. And I videoed it all. And I thought that would make a nice, interesting video maybe for somebody to sit down and watch for a while. I made the T-nut that fits on there. This slides in there. A little bit of it protrudes so that this spacer block always lines up in the right position. That's a bit tight, bit of a tight fit in there. That. And then this Dixon tool post, which came with my lathe, fits on there. The pin drops in there and keeps the whole thing aligned. So that's guaranteed to be square to the axis of the lathe. And obviously do a nut up on top to secure it. Well, great. And I was editing it. And then I decided that I wanted to change my computer operating system as the Windows 10 was going out of date. So I decided I'd try to install Linux on my laptop, and I did. I used it for many years at work, but only as a user. I never built it. And it all worked, and I tried different distros, and then one day I tried one, and the following day when I came back to have a look at the videos, I discovered I just installed it straight on top of all my video stuff. So all that footage, all the editing that I'd already done on it, gone. So sorry, I'm afraid that's one project you won't get to see. However, on a brighter note, one of my viewers contacted me and offered to send me some horizontal cutters, which I graciously accepted, and let's see what arrived. And this is what arrived in the post. It's a marvellous collection. It's more than I'm probably ever going to get round to blunting in my time. There's everything here from 3/4, 5/8, halves, 3/8 quarters, lots of slitting saws. There even appears to be a matched pair of cutters there. It's just large slitting saws is absolutely marvellous. So Bill, thank you very much indeed. This is much appreciated. And so to the subject of today's video. I have an Ainjest threading attachment on my lathe which enables you to thread at a very high spindle speed, and it will stop the cutter at just the right point. Now with these very high spindle speeds, this would obviously take most advantage of carbide tooling, but I tend not to use carbide tooling because I just never have. Whenever you want a particular thread cut, I'd rather just grind up a piece of HSS. If it's a funny thread, it doesn't matter. However, I thought I might make myself some tool holders for some inserts to take advantage of the fact I've got a whole load of blunt inserts that either going to be thrown away or could be reused, and I can repurpose these as threading inserts. Now, the particular angles and orientation that I want these things held, the inserts held in, I haven't seen any commercially available, certainly not at the sort of prices that I would want to pay. So I thought I'd make some myself, and having thought about it, it's much easier than you'd think. So in this video, let's go through the process. I've prepared 2 tool holder blanks out of the same material that I made the rear tool post mounting attachment out of. This is quite tough stuff. This is both of these are 16mm square. I've marked one with an L and one with an R, as my intention is to make a left and a right hand threading tool out of them. Now, to this end, I've got a collection of carbide inserts. These are DCMT 11s. They're all damaged in some way. For example, that's lost the end. In fact, it's lost most of the side as well. But these will provide some useful raw material to grind up into some threading inserts. So the intention is to mount a right hand one kind of like that, and the left hand one kind of like that. The left hand one is intended to be used on the rear tool post because the Ainjest threading attachment only works in one direction, that being towards the headstock, so we have to thread with the spindle in reverse, and the easiest way is to put the tool on the back of the workpiece. So we'll get on, we're going to drill a hole for the center mounting screw and use that to locate these parts on the rotary table where I'll mill the pockets. So first thing we're going to want is a drawing, and this is a drawing I prepared in Design Spark with all the key dimensions listed for how far I've got to move everything to get all the features in the right place. The idea is quite simply to locate the center of the bolt hole there at the center of the rotary table, and then this can be pivoted around and the tool offset in X and Y as per these indicated dimensions. So it's relatively easy to know exactly where this edge will be and that edge will be. I will be middling the sides vertical. They're not going to be 7 degrees that maybe you should correctly mill to get these to allow for the clearance angle on the side of these inserts, but it's much simpler like this. That's located 0, 0 at that corner. So now we've located that corner, which is this corner up here, we'll be moving down by 6mm and in by 9 minus 4.75, which is 4.25mm, to give us the hole location. I'll be centre drilling it. The reason for that will become clear shortly. We won't be using a spotting drill. Do. And now these centre holes are drilled, you can see exactly where I'm intending to mount the inserts. There's quite a lot of stick out, but there's going to be quite a lot of this ground away so that I can form a 60° or a 55° point on these. And looking at the insert from this angle, you can see the idea is to line up the edge of the tool holder with the bottom edge of the insert, not the top edge at this outside here, so that this always protrudes out slightly. So now the purpose of this centre drilled hole becomes clear. I'm going to use that with a 60° cone point in the spindle to line up this, which will become the mounting screw hole for the insert. I'm going to line that up with the centre of the table. The spindle has been previously dialed in to be exactly on the centre of rotation of the table. So now we can bring down this point, lock the spindle there so that's nicely snugged in position. I can now put a couple of studs in here. I have this clamp plate that I can't remember when I made it, years ago. It comes in quite useful for mounting things like this. And just screw these down, trying to keep them far enough away from the insert pocket that we're going to create so that it doesn't foul on the ER nut as it's rotating as we're cutting the pocket. So now I'm going to engage the rotary table worm, and then I'll dial in until the side of the tool, in fact it should be this side really, is precisely parallel to this axis. Then I'll zero the vernier here. Let's get this out of the way. That will do. So now we'll lock the table, undo this set screw, and I'm going to rotate this counterclockwise, making sure the worm is engaged clockwise until that's on 0. Then I've got to go down underneath here and find the set screw again. Just snug that up. Back zeroed on the DRO directly over this hole here. The next job now is going to be to drill through with a 3.3mm drill. Then I'm going to stick M4 taps successively through there to get the thread formed correctly. Yeah, I can feel I'm through as I've hit the aluminium. So I'm going to hand tap this. I've got a set of 3 progressive taps. So the first tap doesn't form a full thread. The second one improves upon it, and the final one actually forms the final thread. These are quite good in fairly hard materials like this because they're not trying to take quite so much all in one go. Okay, so first tap. Take that one out, put the second tap in. The other attraction of these taps is that they don't have a neck down here to create a weak point. They taper down to the thread rather than tapering out to the thread. So these are a little bit more robust. And finally, there it is, one hole tapped M4. First move is going to be to rotate this thing 117.5 degrees. There. And now as a sanity check, if I place that on there, we're going to drill a hole right under where the point of this is. So now we need to move by 10.3 millimeters. There. Now, rather than use a small end mill like a 4 to rough out a lot of this material, I'm going to bring in this 6mm end mill and bulk out a lot of the area. I will only be coming to within 0.5 millimeter of each of the edges because I'm intending to try and put 7-degree angle on each of the edges as a final cut. Let's go back to 0. And now we need to change our angle to 90 degrees. So I need to go back 6 7/8 turn. 6. Let's do a whole extra turn, and then let's go back. So we're approaching from the same direction. The next move is going to be to rotate the part by 27.5 degrees and then mill a 4mm channel in a straight line between the center point of this one and the center point of that. That will form the complete pocket where the tip of the tool will sit, and then these sides can be milled at the correct angle to meet that pocket. So this will end up coming down here. This one will end up coming about like that. So now we're going to go back 6 7/8 turns of the handle. 1/8, 2/8, 3/8, 4/8, 6/8, 7/8. I've left 0.1 millimeters on the bottom there to give me something to clean up with a final pass, which I'll do in one go, one setting, to do the whole lot, so that the whole bottom is flat and at the same level. Now we go back and we need to rotate back again, and we're going to chop this side off here, get this flush, run this cutter right the way down into this groove, so that this is then at the correct position for the bottom of the slot. 4, 5, 6. Now let's do an extra whole turn, and then let's come back and stop at exactly the right point. We're there. So now it's just back and forwards to clean up this side. Now to do the other side of the pocket, I need to, firstly let's make sure we clear the tool, then take the locks off, and it's 13 3/4 turns of the handle in a clockwise direction, so exactly 13 3/4 will do. 13 1/4, 2/4, and 3/4. nicely obscured by the stud there. You can't see a damn thing. There is our completed pocket, almost. What's left to do is to put the 7-degree bevels on each side. And just as a quick sanity check. That fits in okay. It'll go in a bit further once the sides are beveled, because they're 0.5 millimetre proud at the moment, so it's going to push it out. Time now to mill this corner off. This goes the whole depth. So this is where we've got to so far. The last thing to do is to put a 7-degree bevel on both of these faces here. So to achieve the 7-degree bevel, this nut here needs loosening and the whole head can be rotated, and there's a scale here which will be close enough for my purposes. It's either that or else it's going to be a vertical side and just touching on the top, so I'm going to give this a go. And there we are. The head is now tilted over. That means all our coordinates in the X direction are all completely lost, so everything at this point goes on feel. Right, here we are, all ready to go. I've got a little bit of paper in there. I've measured the thickness of the sheet it came from, 0.1 millimeters. So we will get everything going and then machine away at this backside here. I think that's probably good enough. Let's not over egg the pudding here. Right, time to give this one a go then. Right, let's see how we did. I haven't cleaned up the burrs and everything yet, but I'll try this knackered insert in there on the two reasonable faces. So if the insert shatters as I tighten it up, nothing's lost. So that sits in there. Oh, there we are. Fitting very nicely. Well, there we go. There it is. There's a close-up look of what I've achieved. I put a half-decent insert in there. The hole is just towards the back, which is probably what you want. So if I just rest that there a second and attempt on camera without dropping everything. Nice and secure. There we are. The angles at the side just about match the clearance angles on the insert. Now all I need to do is to reprofile the end to act as a threading tool. If I need more protrusion, if when I've ground it back there's not enough clearance, then this face here will just need to be machined back very slightly. But that's fairly trivial. But this face here is flush with the bottom of the insert, so there's clearance all the way down there. There we go. So here are the two finished tool holders. I've given them a coat of cold blue. They've been in the quick change tool holders, so they've already got dented. I ended up putting a little bit of extra relief on the front edge as some of this gets in the way when you're trying to grind the tools. So with that, let's get to actually grinding the inserts. So let's grind up a left-hand tool. So if we pop the insert in the tool holder, tighten that up. Right, that's ready to go. First operation, I'm going to just put a flat, I'm going to get rid of the original cutting edges, all the original relief. So we'll just angle this vertically and let's get the height adjusted. Now, as we're grinding carbide, I've set up some rudimentary extraction here. This is just connected to my shop vacuum cleaner. And off we go. Grinding setup for the first side. This is at 30 degrees, so I'm going to be producing a 60-degree tool, and I've got it tilted back about 8 degrees to give some relief. We're grinding on the bottom of the wheel because otherwise the wheel will take off the bottom of the tool holder. should do. Ready to do the final side. Again, I'm using the bottom of the wheel. You can see the clearance to the tool holder. It's minimal. Same again, just grind the other side until we reach the point, and then we're done. And just like that, it's done. Close-up look at the tool that I've just created. It won't win any prizes for absolute accuracy, but it's got a 60-degree point. It'll need the very end just slightly rounded over. Other than that, it'll cut. Okay, time to do a demo. I've prepared this piece of rod here. This is just under 3/8 diameter. I'm going to put a 16 TPI thread on it and check that this UNC nut fits on here. I'll be feeding in directly. I won't be using the compound, and I'm going to run the lathe at 540 RPM throughout and use the Ainjest to stop the tool in the right place. I'm also not going to be cutting a run-out groove down here. I'm just going to let the tool cut its own groove when it's finished cutting, and we'll see how that gets on. Right. Right, uncut. Let's see whether it fits or not, whether we need to take any more. Another couple of thou, I think. It's almost there, it's going. Probably needs a bit of a deburr as well, but first we'll just run a file over it and see whether or not that helps clean things up. It's really tight once it starts getting on there. A couple more thou. It's all right, that works okay. Okay, second demo. Here I've got a piece of material I've prepared. This is 0.311 diameter. So I'm going to put a 5/16 18 thread on it. And to check it, I've got this delightful little nut, which if you look closely you might notice it's got LH written on it. Now this nut was in a batch of nuts that I bought ages ago, and it's one that didn't want to fit on the thread until I spotted the LH and then realised it's not going to. But it'll be very useful to check out this one with a left-hand thread. So there are different ways in which I could achieve a left-hand thread on here. Because I'll be using the Ainjest, we have to move the tool this way, because the Ainjest doesn't work if the tool is retreating from the headstock. So I could flip the tool upside down and run the spindle in reverse. Or what I'm going to do is to use a rear mounted tool post. And this is my rear mounted tool post. The bottom was a copy of a Harrison original, or my interpretation of it, based on the material I had. I have a riser block on here to get everything up to the right height, and I've got the Dixon tool post that came with the lathe, and I've got 3 tool holders for this. So I wasn't going to use this Dixon tool post as the main tool post for the lathe, because I've got rather a lot of tool holders for the wedge style that I use. That looks like it's on centre height. Right, everything's set up to go. Everything in this tool post is all keyed in together so that this riser block always sits in the same position. I've got this pin in here, which is a nice tight fit, which makes sure that the tool post is sat exactly square to the axis of the lathe. The tool is sat right up against the back here, and when I check, everything's nice and square and exactly where it should be. The final check with the tool clear of the work. Looking good. A little bit of oil and off we go. Very nice. Looks like a fluke, that one, but there we are. There we have it. 2 homegrown tools, suitable for cutting threads on this machine with the Ainjest, where the spindle speed is much higher. There's our left-hand thread, and there's the right-hand thread. A success. So there we are. Hope you enjoyed the video. Thanks very much for watching.